Hello, my awesome AP comers. Today we're going to do a demo about indicators. There are hundreds and hundreds of indicators out there. Some are naturally occurring, like red cabbage, red onions, beets, the red in the rose petals, and so on. And some are man-made or synthetic. So I'm going to show you some of the most common indicators that we find in the lab. And so you've probably heard about pH paper and litmus paper. Litmus paper comes in, there is blue litmus paper and red litmus paper. So I know it's kind of hard to see the colors. This is the blue litmus paper and this is the red litmus paper. I'm going to kind of hold them against my white shirt here so you can kind of see them. So this is pink, it's the red one. And then this is the blue, it's kind of almost a purple color, like a light lilac color. When you put them in a neutral solution, they remain the same color, but so the blue one remains blue, the red one remains red, but when you put them in an acid, they will be red. So red will remain red, blue will turn red, and in a base, they're gonna be blue. So I have let's start with the blue here, the blue litmus paper. So I'm going to start with HCl, and I'll put a drop of it on here. And hopefully you can see that the blue one turned red when I added the acid to it. The next one, let me get my speaker here. The next one, I'm going to dip it in water. And you can see that the blue remained blue, just a little wet, but it stays the same color. And then for the base, here's the base that kind of keeps it pretty much blue. So base is blue. So acid is red, base is blue, neutral keeps it the same color, whatever it was. So now I'm going to look at the red litmus paper, the one that's kind of like a pink color. So I'm going to start with the acid, a little bit of acid on it. And there's HCl on it. You can see it's still red or pink. In a neutral solution, again, still red or pink. And in a base, it should turn blue. So this is NaOH, which is basic, and it does turn blue. You can kind of see that it's definitely a different color from what it was before. Next is pH paper. You're probably more familiar with pH paper. So pH paper is kind of like an orange colored paper. Looks like this. On your screen, it might be orange or yellow, kind of. Again, in a neutral solution, it will remain the same, but it's pretty cool because it turns all kinds of shades of colors. So in an acidic solution, it's going to turn like an orange or a red. In a basic solution, it's going to be purple or blue or green. So I'm going to start with my acid. I'm going to add a drop of acid on it. And you can see it turned red. This is 10th molar HCl that I used. In water, it remained the same color. And in a basic solution, you can see it turned like a dark blue color. Do a few more indicators. Next is phenolphthalein. Phenolphthalein is one of the most used indicators in the lab. If we were in school, we would do an acid-base titration, and we'll talk about titrations a little bit more in the next videos. But usually phenolphthalein is one of the most common indicators that we have. So I'm going to go ahead and turn the camera right here. So I'm going to add phenolphthalein, which is a clear colorless solution to my acid here. I'll put a couple of drops in the acid, put a couple of drops in water, and then a couple of drops in NaOH. And I'll mix them together so you can see it a little bit better. So there's in the acid. So it should remain colorless, or sometimes it turns like a cloudy white like that. It's just turning cloudy white because phenolphthalein is dissolved in alcohol, and the alcohol is not really mixing with the water very well. But it's usually like a, we can say it's a colorless color, I guess. But in a base, it turns this bright, pretty fuchsia. So it's pink or fuchsia in a base, but it is colorless in an acid or in a neutral solution. It actually turns at a pH of 9, this pretty pink color. The next indicator we're going to use is called methyl orange. So for methyl orange, I'm going to turn to these 3 right here. And we'll do the same thing. So we're going to use HCl, water, and NaOH. So acid, neutral, and base. And so there's a drop in the acid, neutral water, and the base. Methyl orange, the range of it is orange or red. So you can see in an acid turns the red color, neutral, it's orange, and in the base it's also orange. And so again, methyl red only has the ranges of red and orange, and I think it turns it around pH 5. So 5 and below, more acidic, would be red, and then 5 and above, so neutral and base, would be an orange color. And then my favorite indicator, my absolute favorite, is universal indicator. So universal indicator is my favorite because it turns all colors of the rainbow. So I'm going to go ahead and do the same thing. I have HCl, which is an acid, water, neutral, and then NaOH, which is the base, and I'll put a couple of drops in each of them. And you'll see that in an acid, it's a red color. When it is neutral, it is a green color, and then in a base, it is a purple color. Now, in reality, like I said, it actually turns all colors of the rainbow. So green is neutral, it's pH of 7. But if you get like a yellow or an orange or a red, those are all acidic. If you get a blue or a teal, blue, or purple, that would be a base. So I want to show you another demo of universal. I got this tube and I filled it with water and universal indicator. Remember, it is green when it's neutral, so it's green. And then to this side, I opened it and added a couple of drops of acid. And on this side, I opened it and added a couple of drops of base. And you can kind of see, you see all the colors of the rainbow. It's pretty cool. So again, where it's green, that's neutral. Any blues or purples are basic, and any oranges, yellows, or reds are acidic. So it looks like I added a little bit more base than I did acid here, but you can see it's turning all kinds of pretty colors. So I would like you to try to use an indicator at home. Probably the best indicator that I've used at home, like, natural indicator, is red cabbage. So if you are able to buy some red cabbage, you can use the leaves, just the leaves by themselves, or you can, the best results are really if you boil a couple of leaves and use that water. It's really cool if you add some of that water to some soap, for example, that's a base, or some vinegar that's an acid, or Sprite, lemon juice, any cleaner like Windex or something, toothpaste. You can add it to all kinds of different things and see if they're acidic or basic. So if you look at our Teach an Adult at the end of the packet, it tells you to use red cabbage juice. I was going to give that to you, but unfortunately, of course, I can't. So you can make it at home, or you could research about any other natural indicator and try it. Red cabbage juice is actually pretty cool because it turns all kinds of different colors. And I use it when it's Easter time to naturally color eggs. So I do water, which is neutral, boil an egg in it, and then I also boil it with some vinegar, which is an acid, and then I also do baking soda, which is a base, and it turns all kinds of pretty colors. So you can try it at home for coloring eggs for Easter, since Easter is coming up soon, or just use it to do Teach an Adult. And I'd like you to try, if you can, if you're able to teach an adult and turn it in. Give me, like, take a picture of what you did and share it with me. All right, that's all for now. Thanks for listening. I'll see you next time. Bye.